Hey y'all, Miss Brown here, your 8th grade science teacher. Yeah. So this is for Friday, September 25th, I believe. Look at my hand, y'all. I had my kids guess a number and I had to write it all down to show that I wasn't fibbing. Okay, so I'm going to go to module 7, even though it was technically module 6, and then I will hop back. So what we did on Friday was we went over the station labs that we did breakout rooms for. Sorry, y'all, my hair's all about. So let's talk about that. So we went to Friday, Explore Friday, 9:25. And like I said, we reviewed pages 2 to 6 in our journal to start. So hold on one sec. Let me go grab it. Pass it back on. Okay, so trusty dusty journal. And y'all should have the essential question written at the top and then the rephrase on the bottom. And we're going to be using that this week for our podcast. So first thing we did was we went over page 2 in our journal. So we went over this concept map. So I am going to pull it up so that way I can talk about it and you guys can see what I'm doing. So concept map is like, I call it a concept map, but a lot of people call it a bubble map. Any of those terms are fine. So give me 1 minute. Let me hop back to show you all about that concept map. So the title of the concept map is atoms, and that was one of the words on the word bank that you can cross off. So right here should say atoms, and then you can cross atoms off of your word bank. And then we'll go over those discussion questions as well. Y'all, I should have just went to the module. That would have been easier. I'm already here, so oh well. Okay, so these are the words you need to use. Atom, nucleus, proton, neutron, electron clouds, and then positive, negative, and neutral. So right here, this should be atoms. And then you need to think, what is like the location of these particles? Because that's what's going to differentiate between this left side and this right side. So right here is going to be nucleus because some of the particles are located in the nucleus of the atom. Y'all, I'm not playing. My face itches every time. It's so weird. And then here, what's not the nucleus? The other particle, which is in the electron cloud. So we have atoms, we have nucleus, and then we have electron cloud. So let's start with the right side first. So what's in the electron cloud? The electrons. And what are the charges of electrons? Negative. So you have atoms, electron cloud, electrons, negative. And then here you have atoms, nucleus, and then what two particles are found in the nucleus? You have your protons and your neutrons. And your protons are positive and your neutrons are neutral. Some people did nucleus, proton positive, neutron neutral. I wouldn't do it that way because the concept map, you're supposed to follow the line. So to me, this is nucleus, proton positive, nucleus, neutron neutral. Or if you swapped and had neutron neutral, proton positive, that's fine. But you definitely want the particle with the charge to go below because this line indicates that it goes down that way. However, if the line went that way, then it would be a different story. So one last time, since I'm not writing it, atoms, electron cloud, electrons, negative. Atoms, nucleus, neutrons are in the nucleus and they're neutral. And then nucleus, proton, positive. Awesome. So that's what we did on Wednesday, and we went over that on the start of Friday because Thursday we started our breakout rooms. And then the answers to our discussion questions. So just how small do you think an individual atom is? Y'all, individual atoms are microscopic. I don't know the exact number, and I should because I'm a science teacher, y'all, and I should just have these memorized. But it's something like billions and billions in just the dot of a pencil side by side. So they're microscopic, teeny tiny. Like I said before, if the nucleus of an atom was the size of a penny, the first shell of electrons would be a football field about half away. So they're teeny tiny. Protons don't stick together because like charges repel. And if protons are positive, then two same charges repel. Think about a magnet. If you have two north poles, you go to push together as hard as you can and they keep bouncing back. Opposites attract. So a plus and a minus would attract. So protons don't stick together because they're the same charge and they repel. And thankfully, those neutrons are there in the nucleus to kind of help them stick together. An atom can't gain or lose proton gel because it changes the identity of the element or the atom. Carbon has 6 protons. If it has 7 protons, then it's nitrogen. And if it has 5 protons, then it's boron. So the proton is like the fingerprint. It's the identity of the atom. Electrons can change, and that's called an ion. And then you can change the number of neutrons, which is called an isotope, which we'll learn about later. The space between electrons, y'all, empty space, like nothing. There ain't nothing there. So exactly like I said with the analogy of the penny and the 50-yard line, and it's going to be like a football field and a half away. It's mainly empty space. And the electrons just orbit like the planets around the sun, around the nucleus. What do you suppose would cause an atom to lose an electron? So y'all, plenty of different reasons. And when atoms and elements bond together, that's what they do. They lose their electrons. So this electric kind of charge, this electric energy is released. So atoms either gain or lose electrons to react and form bonds with other atoms, which is pretty cool. So don't forget to add pages 1 with your EQ and your rephrase, and then your bubble map with these questions answered to your never-ending slideshow. Okay, moving on next. So what we did on Thursday was we did these breakout rooms, and I didn't help y'all at all. I know it was tricky. And then on Friday, we met back as a whole class, and we reviewed all of the answers to the breakout rooms. So I'm going to walk through it to talk to y'all about the answers. Okay, so this is page 3. So if you go to the next page of your journal, this is page, I can't stand when I can't see it, right there. So page 3 of your journal. So it's going to be 3, 4, 5, and 6 because there's 4 stations. So y'all, I talked about this before, I think, but I might be going crazy. So electrons are very light, protons are heavier. Protons and neutrons are about the same, so 1 AMU atomic mass unit. And then there's about 1,836 electrons in 1 proton, and since protons and neutrons are the same, there's also about 1,836 electrons in a neutron. So electrical charges, protons are positive, neutrons are neutral, and electrons are negative. Neutron compares to a proton because they're equal. Proton compares to electron by being a lot heavier. About 2,000 electrons is a proton. And then same thing, about 2,000 electrons is a neutron. And in what area is the majority of the mass found? It's found in the nucleus. So y'all, I really feel like I actually did go over these. So I'm going to kind of just zip through them because I think I did in my last video. Can't even remember. So for each atoms, we can observe that there's protons and neutrons in the nucleus, and then there's electrons orbiting in what we call shells or rings. I can tell that there's 2 electrons in the first shell if it's full, and then if there's another electron, it has to go in the next shell. I'm noticing for aluminum, there's 2, 4, 6, 8, and then it bumps to a 3rd shell for the next 2. So I'm noticing that there's 2 in the first shell and up to 8 in the second shell. I'm also noticing that the protons and the electrons match. 2 protons, 2 electrons, 11 protons, 11 electrons, 6 protons, 6 electrons, 13 protons, 13 electrons. I'm also noticing that sometimes the neutrons match. So we have 6 of each here, and we have 2 of each here. But then for the case of aluminum and sodium, I'm noticing that there's an extra neutron in both. So I'm noticing that sometimes neutrons are not the same. Atoms are different from each other, y'all, by the number of protons, the identity, the fingerprint of the element. And some unanswered questions. We did talk about this the last time. I remember talking about drawing them. And you can draw them 2 different ways. You can actually draw the dots, but I prefer the number. I prefer something like this because ain't nobody got time to count all those dots, y'all. Come on now. I'd much rather you put P equals 11 or 11 plus than 11 dots because I can't count all those. I got old, tired eyes. And then for your electron rings, you can do something like draw the ring and then put the number 2 minus or 2e minus. So that way I don't even have to count your dots around. That'd be super awesome. And then station 3 was that one. And then station 4 is the next one. And station 4, y'all, we talked a lot about this. The periodic table of elements, the periodic square. Let me find periodic table. The element square tells you all the information that the atom picture tells you. So let me find a good periodic table that I like. So we call this an element square. It's organized by atomic number. And my man Dmitry Mendeleev created the periodic table of elements. And this is the electron square right here is what we're talking about. So I'll click on this, y'all, but I don't know if it's going to be blurry when I click on it. Okay. Where's the periodic table, yo? Come on now. Here it is. Yeah, that's fine. We can do with it. Okay, so atomic number is this number at the top, and that tells you the number of protons. Then you have the, ooh, is it going to make it bigger? Yes, y'all, perfect. So the atomic number tells you the number of protons. So hydrogen has 1 proton. Protons and electrons are always equal in a neutral atom, so it also has 1 electron. I know that its name is hydrogen, its symbol is H, and its atomic mass is 1.008. So I'm going to teach you, and I'll talk about it now, to find the number of neutrons, you take this atomic mass and you round it to the nearest whole number. So 1.008 rounded to the nearest whole number is 1. And then you subtract the atomic number from it. And that's it, y'all. So 1 minus 1 is 0, which is why hydrogen is the only element with 0 neutrons. So it has 1 proton, 0 neutrons in the nucleus, and then 1 electron on the first ring. So y'all, now let's say we're doing beryllium. So what's beryllium's atomic number? 4. So how many protons does it have? 4. How many electrons? 4. And then we figure out neutrons by taking this bottom number atomic mass and rounding it either up or down to the nearest whole. Remember, if it's 0.4 and down, you go down. If it's 0.5, you go up. So 9.01 is going to round down to 9. And 9 minus 4 is 5. So beryllium would have 5 neutrons in the center, 4 electrons, because its atomic number is 4, and electrons and protons are the same. So 5 N0, then 4 protons, 4 plus in the center with the nucleus, and then you would have 4 electrons around the outer edge. Remember we talked about how many electrons fit in the first shell? 2. So if you have 4 electrons, you're going to have 2 in the first shell and then 2 in the second shell. So you notice that beryllium is an instance where you have more neutrons than protons and electrons. But does that affect the charge of the atom, y'all? No, it doesn't. Because what charges are neutrons? Neutral. So if you have 4 plus and 4 minus, they cancel each other out, make 0, which is a neutral atom. And it doesn't matter how many neutrons you have, y'all, because they are neutral, which is pretty cool. Okay, let me move my evil twin. Awesome. So type of information the periodic table gives, it gives you the atomic number, which tells you the number of protons and electrons. It gives you the name, the symbol, and then it also gives you the atomic mass, which you can use to figure out the number of neutrons. And then, y'all, we'll also talk all this other stuff about what these different colors mean, all this keys, and then there's even more information based off of what column or what row it's in. I'm gonna blow y'all's mind. You just wait. Okay, sweet, sweet. What kind of information is found both on the element and the periodic table? The same, because if I look at this picture, I can see how many protons, neutrons, electrons. And once I know a little bit more about the periodic table, I'll be able to even figure out where on the periodic table it is without even looking at the periodic table. It's like magic. Can you determine the number of neutrons by looking at the periodic table? Yes, I just taught y'all how. Do all atoms seem to have equal subatomic particles? No. They always have equal protons and electrons in a neutral atom. That's not an ion. But sometimes they might have different neutrons. It kind of just depends on the look of it. One sec, hold on, y'all. Hey, y'all, sorry, podcast question. Makes me so happy. So can you draw a model of an atom from the periodic table? Yeah. Because you know the protons, you know the neutrons, you know the electrons, and we know that 2 electrons fit in the first shell and up to 8 fit in the second shell. Okay, rock on. So I think that's it, guys. I'm going to make a second video to talk about the podcast today because I want to be able to have them be separate videos. So you did pages 3, 4, 5, and 6 for the lab. And then for homework over the weekend, I had y'all annotate and text code this using the key that I put on Canvas. So yellow, or you can underline parts of an atom, then green or circle characteristics or traits, and then blue or question mark any questions you have. And then do a quick summary or gist statement. So as of Friday the 25th, you should have pages 1 through 7 uploaded with pictures to your never-ending Google slideshow. And I think that's it, y'all. Love each and every one of you. You fill my buckets each and every day. Don't forget to fill out this Padlet. That was also part of your homework in addition to this. So what's matter? How small is an atom? How is the space occupied by an electron compared to the nucleus? Where are electrons located? What is a proton? What's its charge? And what is a neutron? What's its charge? And how do you find it? And I think that's it, y'all. Bye. Have a good day, and I'll see you in a minute.